My name is Tristan Davis, and I'm going to be doing a speech about modern renewable energy. By the end of this speech, you will all have a firm understanding about modern renewable energy generation, in which includes these three topics: hydroelectric generation, wind generation, and solar generation. There's other kinds as well, but we're not going to cover those in this. So we'll jump right into hydroelectric generation. Hydroelectric generation is the use of flowing water through a dam to spin a turbine, which in turn will generate electricity. There are more than 2,400 hydro stations that generate power in the U.S., including the Hoover Dam, which is one of the largest in the country. Hydro plants often have constant water flow, so they are always generating base load power because it's low cost and consistent. So what base load power is you run the dam at one level all the time, so it's always a constant generation. And then when the power consumption fluctuates, because lights shutting on and off, all different stuff, when you're running an AC unit, it turns on and off, that fluctuates the power draw. So all the other generating stations in the area will do that, and a base load plant will run steadily all the time. This is a drawing diagram of a hydroelectric plant. So this would be your water reservoir side. You have water from behind your dam, goes in, flows through the penstock, which is the term for the pipe that runs into the turbine wheel. The turbine is then in turn spun by the water flow, which turns the generator and generates power, and then your discharge water comes out and flows out of the dam. Cost and effects of hydro. One downfall of hydro generation is that dams are very expensive to build. The Hoover Dam was built in 1936 and cost $49 million, which is worth $917 million today. Building dams also floods natural habitat and can drive away native wildlife. And the average price of hydro generation per megawatt is $400,000. So to build a dam that would make 1 megawatt would cost $400,000, and it goes up from there depending on how many megawatts the dam would be. So now we'll move on to wind generation. We're all from the Midwest, so I'm sure that all of us have seen the big fan-looking things that are all over the bluff over in Missouri, right along I-29. Those are wind turbines. Wind generation is a relatively new generation style, become popular in the last decade. More than 30,000 wind turbines have been installed in the U.S. since 2010. And wind is also, obviously the wind is always fluctuating. It's a very inconsistent generation source. So when the wind is fluctuating, it causes stress on other conventional power generation stations like coal plants and combined cycle plants, gas turbine plants, because they have to move around, because when the wind fluctuates, all the wind turbines, their energy output changes, and then the conventional plants have to adjust to follow that. The average utility scale wind turbine, which is the big white ones that you see all along the highway, not a little one like you would have in your backyard. Utility scale is 280 feet tall, and each one of the blades is 120 feet long, and they can adjust their pitch so that they catch the wind more effectively and can operate at, what word am I looking for? Anyways,
maximum efficiency.
the part of the blades, the part that the blades are attached to is called a nacelle. So that's the big part that the rotor goes on, and that actually rotates 360 degrees to catch the wind. So it's facing directly into the wind. And the distance between each wind turbine is 7 diameters of the rotor rotation. So being that the blades are 120 feet, the diameter is 240, so there's 1,680 feet between the base of each wind turbine. Cost and effects of wind. Wind turbines have a specific range of wind speed required for running, which is 8 to 16 miles an hour. This causes them to only run an average of 33% of the time. So 77% of the time, the wind turbines are not spinning or generating any source of power. Depending on your location, obviously, geography has a big impact on that, but this is average. Wind turbines also take a toll on bird and bat populations. Since the wind is unpredictable and it varies, so does the output of the wind turbines, which I mentioned earlier, which means that conventional power plants have to chase the load variation, causing significant stress on components because they're constantly accelerating and decelerating. The most common utility scale wind turbines are 2 megawatts in capacity and cost $2 to $4 million each, meaning that wind generation on average is $1 to $2 million per megawatt installed. Now we'll move into solar generation. Solar generation is a process of using photovoltaic or PV solar cells to convert the sun's UV rays into electricity. Solar generation is becoming more and more common nowadays. You can look around and find them in rooftops in Lincoln, and if you're going on I-80 West, there's a new solar farm right there on the north side of I-80 as well. The cost of installing solar generation has dropped significantly by nearly 70% in recent years due to technological advancements and the spread of solar panel manufacturing to countries like China. Because China can manufacture them way cheaper than we can in the States. This right here is an image of a solar farm in Little Rock, Arkansas. This contains 300,000 solar panels and it takes up 475 acres. But taking up that much, for what space it takes up, it only generates 12 megawatts, which is not very much. Some solar panel facts. More than 60% of the world's solar panels are made in China, where manufacturing pollution is regulated far less than other countries. So the pollution that comes from making solar panels is actually quite a bit because they use a lot of chemicals. They use caustic chemicals and they're made out of all petroleum products. So it's a lot of pollution that is made or caused during the manufacturing process of solar panels. Solar panels have an average life expectancy of only 15 to 20 years too, depending on the quality of the panel. So when solar panels reach their life expectancy, they don't perform well anymore and they just get thrown away in landfills. So every 15 to 20 years you're cycling through panels and those are just piling up in landfills too. So that's a lot of pollution. Also, solar panels produce direct current, which is not what we use in like regular outlets. We use AC power. So to convert that, you have to send power through an inverter, which transforms it to AC, and then it can be put on transmission lines and sent out for regular household use. So that's an extra process too, that bumps up the cost. Solar generation, on average, or the average cost of solar generation is $290,000 per megawatt. Solar panels have a life expectancy of 15 to 20 years, and then they're thrown away. I mentioned that in the previous slide. And solar panels take up a lot of space, 6 to 8 acres per megawatt. Whereas wind turbines only take up 2.5 acres per megawatt. So significantly less area for wind turbines and solar panels. And also solar panels only generate their peak output for a few hours a day when the sun is right up at noon time, when the sun is at its brightest. And it's also affected by weather patterns, like if it's raining or cloudy, you're not going to generate hardly any power. So that's another thing that brings down the efficiency of solar panels. So in conclusion, renewable energy is a good addition to the modern power grid, but it has many disadvantages as well, such as it's far more expensive and inconsistent than conventional power generation. But on another note, renewable energy does produce a pretty decent amount of energy with no carbon output after the manufacturing process is over. If renewable energy is going to take over and grow in the modern world, they have a lot of technological advancements to make. one of those advancements is there's no way to store that much power, and when the wind's not blowing or when it's nighttime, conventional generation has to take over. So if we were running an all renewable system, we would have no power at night or when the wind's not blowing, because there's nothing to make up for the loss of sun and wind. Any questions from the audience? Pretty good.